All right, let's talk about one of the biggest buzzwords out there, machine learning. We're going to cut through all the hype and get right to the core of what it is. And here's the fun part. We're not just going to tell you. You're about to figure it out for yourself.
So, to kick things off, I've got a little challenge for you. I want you to forget about computers, forget about code. Just use your own brain for a second.
Okay, so look at this sequence of numbers. 1, 3, 5, 7, 9. What do you think comes next? I'll give you a second. You can feel your brain doing it, right? It's scanning for the pattern, trying to figure out the hidden logic.
You got an answer? Good. Now, whatever mental gymnastics you just did to get there, hold on to that thought. Because you've just stumbled upon the entire secret to understanding machine learning.
Yeah, the answer is 11. I bet you got that pretty much instantly. Your brain just saw it. Maybe you noticed you're just adding 2 each time. Or maybe you just recognized, hey, these are the odd numbers. So in machine learning lingo, that rule you found, that hidden pattern, that's what we call a model. We could even write it out as a little formula, y equals 2x minus 1. That formula is the model your brain just created.
And this is the big aha moment. Seriously, by looking at the examples and figuring out the underlying rule, you literally just performed the same core task as a machine learning algorithm. It's really that simple.
So let's just quickly recap what your brain did. First, you looked at the data, the numbers 1, 3, 5, and so on. Then, step 2, you inferred the rule. You built the model. And finally, step 3, you used that rule to make a brand new prediction, 11. Data, rule, prediction. That is the essence of machine learning. Now, I know that sounds super simple, but that little process, it basically turns the entire history of how we've talked to computers completely upside down. And this diagram right here, it shows that flip perfectly. This is the fundamental, crucial difference between the old way and the new way. Okay, think about it like this. For decades, programming worked one way. You, the human, write the rules. You feed those rules and some data into the computer, and it spits out answers. But machine learning flips that script completely. You give the computer the answers, examples of what you want, and it figures out the rules for you. It learns by example, just like you did.
So if the machine is learning, what does that process actually look like? Well, thankfully, there's a really clean, formal definition that gives us a solid framework to think about it.
Yeah, according to an AI pioneer named Tom Mitchell, any real learning problem has 3 key ingredients: the task, the performance measure, and the experience. Just remember, TPE.
All right, so let's start with T, the task. This is just, what do you want the machine to do? It usually falls into a few major types. The first is supervised learning. This is exactly like our number puzzle. You give the machine a ton of labeled examples. This is spam, this isn't spam. This is a cat, this is a dog. And it learns to predict the label for new things.
Then you have unsupervised learning. This is different. Here you just dump a whole bunch of messy, unlabeled data on the machine and say, find the patterns. This is great for things like finding natural customer groups for marketing or spotting weird credit card transactions that don't fit the normal pattern. And the last big one is reinforcement learning. Now, this is all about trial and error. You have a little digital agent that tries things, and you give it a reward for good actions and a penalty for bad ones. It's how we get computers to master incredibly complex games like chess, or even teach a robot how to walk. And that brings us to E for experience, which honestly might be the most crucial piece of this whole puzzle. Experience is just another word for data, a whole lot of data. Whether it's pictures, text, or sensor readings from a car, the data is the raw material for learning. Without it, you've got nothing. You know, all these ideas, supervised learning, neural nets, they're not actually new. Some of them have been floating around for decades. So why does it feel like machine learning just took over the world overnight? Well, it turns out there was a very specific Big Bang moment. Just look at this quick timeline. The theory goes way back to the 1950s. We had key breakthroughs in the 60s and 80s that are still fundamental today. But then you get to that last entry, 2012. That's when, as one source put it, the craziness really started. So what was it? What on earth happened in 2012 that just lit the fuse on this whole AI revolution we're living through right now? It all came down to this massive competition centered on a data set called ImageNet. We're talking over 14 million images, all labeled by humans. The challenge was simple. Could a program learn to correctly identify what was in all these different pictures? And this one entry, a
a special type of AI called a neural network named AlexNet stepped up to the plate. You have to understand, for years, the best programs in the world really struggled with this. The top error rate was stuck at around 26%. That means they were flat out wrong more than a quarter of the time. It was a really, really hard problem.
Then in 2012, AlexNet didn't just inch past the record, it smashed it. The error rate plummeted, all the way down to just 15.3%.
I mean, that was a leap so huge that researchers at the time called it unheard of. That was the moment. That was the shot heard around the world for AI. It was the first real proof that if you had a big enough neural network and enough data, you could solve problems people thought were impossible.
In that one competition, machine learning proved it could see and understand the world in a way no computer program ever had before. And that just opened up this incredible question we're still trying to answer today. If it can learn to see, what will it learn to do next?